Building a heavy metro system directly under the mighty river Ganga? Let's trace every single mechanism from A to Z. First, advanced sonar grids map the shifting riverbed. To keep the waterlogged soil from collapsing during excavation, engineers formulate a high-density bentonite slurry. This specialized fluid creates a protective seal inside the earth. Next, we dig down 33 meters to build India's deepest metro station. Massive hydraulic grabbers excavate a colossal cavern to serve as our launch pad. We cast thick diaphragm walls around the pit. We use a water-resistant concrete formula packed with microsilica to lock out millions of gallons of surrounding groundwater. The heavy machinery arrives. Giant cranes lower and assemble a 4,000-ton earth pressure balance TBM, specifically engineered to withstand riverbed pressures. The cutting head begins to turn. Spinning tungsten teeth chew through the treacherous alluvial soil, while high-pressure jets blast conditioning foam to stabilize the digging face. Inside the control cab, automated computers maintain earth pressure balance. By calculating the exact soil counterpressure, the machine safely prevents the riverbed above from collapsing. To guarantee zero leaks for a century, every single concrete segment is lined with a high-performance hydrophilic rubber gasket that expands if it touches water. The TBM's robotic erector arm moves with absolute precision, assembling a permanent, interlocking concrete structural ring against the raw sub-river earth. High-strength steel tie rods are driven through the frame. Hydraulic tensioners pull them tight to clamp the independent concrete rings into one solid, unbreakable tube. Boring beneath the river means passing ancient heritage structures on the city banks. Laser monitoring systems track ground movements down to fractions of a millimeter. As the shield advances, fast-setting cement grout is forced under high pressure into the empty gap outside the ring, locking out the river water forever. For passenger safety, cross passages are carved between the twin tunnels, utilizing heavy pressurized airlocks to keep the workspace completely secure. With the shell complete, automated flash butt welding systems fuse the heavy steel tracks together, creating a seamless, ultra-smooth rail line. Next, we run the high-voltage overhead traction lines and install automated signaling infrastructure to fully power the rapid communication network. To let passengers know they are traveling right below a massive river, a spectacular grid of blue LED indicator lights illuminates the underwater zone. After months of dark underground excavation, the spinning cutting wheel finally breaks through the target wall, hitting daylight on the opposite bank. Look at this spectacular cross-section. The metro tunnel sits safely embedded deep inside solid bedrock, completely isolated beneath the sand and layers of the river above. And there it is, a landmark achievement in mega civil engineering, India's first underwater metro crossing the river Ganga in just 45 seconds flat. The Ariane Nova mechanism is now engaged. Watch as it transitions to full power. Witness the spectacular glow of future engineering. Safe, secure, and